Welcome back to the Quantum Thread, Weaving the Future of the Internet podcast. Today, we're diving headfirst into something truly revolutionary, something that could fundamentally change how we interact with the Internet and our data. We're talking about Vogon and their vision for a decentralized cloud. I'm Paul, and with me today, I've got our resident visionary, Susan, our skeptical but brilliant engineer, Joe, and our detailed deep diver, Jill. Guys, it's great to have you here.
Thanks, Paul. I'm genuinely excited about this topic. It's not just about tech, it's about freedom.
Freedom, huh? Sounds like a big promise. I'm ready to be convinced, but I've heard revolutionary a lot in this space. Let's see if Vogon lives up to the hype.
Oh, it does, Joe. The engineering behind it is quite compelling. I've been poring over the white paper, and there are some genuinely innovative concepts.
Perfect. So, Susan, let's kick it off with the big idea behind Vogon. What are they trying to achieve, really?
All right, so the big idea is massive, Paul. It's about taking back control from the centralized giants. Think about it. Google, Amazon, Microsoft, they control vast swathes of the Internet's infrastructure. Vogon wants to decentralize that power. They're building a cloud infrastructure that's distributed, secure, and most importantly, private. It's about empowering individuals, giving them sovereignty over their own data and computations, creating a truly private Internet environment.
But isn't the current cloud market booming? I mean, AWS, Azure, GCP are growing like crazy. Why disrupt something that's clearly working for so many businesses?
That's a fair point, Joe. It is working for a lot of businesses, but at what cost? Centralized clouds inherently create single points of failure. We've seen outages, data breaches, and let's not forget the control these monopolies exert over content, pricing, and even terms of service. Vogon aims to address these fundamental flaws by building a more resilient, transparent, and equitable infrastructure. It's about future-proofing against those risks.
Exactly. So, Jill, how does a decentralized cloud, specifically Vogon's approach, better support something like continuous integration, or CI, which is so critical for modern development?
This is where Vogon really shines. For CI, consistency and reliability are paramount, right? You need to know that your code will behave the same way every time it's built and tested. Vogon introduces deterministic concurrence. This means that given the same inputs, a computation will always produce the same output, regardless of which node executes it or the specific hardware. In a traditional distributed system, you can get race conditions or subtle environmental differences causing non-deterministic bugs. Vogon's approach, through its Vogon Virtual Machine and towels, guarantees this determinism, making CI pipelines far more reliable and reproducible.
And from a broader perspective, think about the resilience. If one centralized server goes down, your CI pipeline might halt. With Vogon's decentralized structure, your tasks are distributed across multiple nodes. If one fails, others pick up the slack seamlessly. It's an inherent fault tolerance that centralized systems struggle to match without significant, costly redundancy efforts.
Okay, deterministic concurrence sounds pretty impressive for CI. But how does Vogon actually achieve this? And you mentioned towels. What are those, and how do they fit into this decentralized cloud picture?
Excellent segue, Joe. Jill, let's hear about these towels. What exactly are they? Are we talking about beach towels, or something a little more codey?
Definitely more codey, Paul, though I do enjoy a good beach towel. In Vogon, towels are the fundamental compute units. Think of them as isolated, deterministic, and concurrent microservices. They're like highly specialized, super secure, and self-contained Docker containers, but specifically designed for Vogon's decentralized network. Each towel executes a specific piece of code or application logic, managing its own data in a fully isolated environment. This isolation, combined with the Vogon Virtual Machine, is what guarantees that deterministic concurrence we just talked about.
So instead of running an entire application on one big server or even a few virtual machines, you're breaking it down into these tiny, independent, verifiable pieces. It sounds incredibly efficient and secure.
I get the microservices idea, but how do towels compare to, say, DAMP smart contracts on a blockchain? Aren't those also small, isolated pieces of code?
That's a crucial distinction, Joe. Smart contracts are fantastic for immutable, trustless transactions and simple logic that needs to be permanently recorded on a public ledger. They're often limited in complexity, execution time, and data storage because every node on the blockchain has to execute and verify them. Towels, on the other hand, are designed for complex, stateful applications. They can handle rich data structures, persistent storage, and operate in a private execution environment. Think of them as robust, full-fledged application components, akin to traditional microservices but decentralized and deterministic. They compute off-chain, but their execution can be verified by the Vogon Consensus Protocol, allowing for much greater scalability and complexity than typical smart contracts.
So, smart contracts are like simple calculators for public transactions, and towels are like mini, private, super reliable computers for complex application logic? That makes a lot of sense.
Exactly. And the privacy aspect of towels is huge. With many smart contracts, the code and even some data might be public. Towels allow for applications to run privately, maintaining user data sovereignty without sacrificing the benefits of decentralization.
Okay, I'm starting to see the power here. So, deterministic concurrence is the magic ingredient, and towels are the little workhorses that make it happen. Can you tell us more about how Vogon achieves this deterministic concurrence technically? It sounds almost too good to be true in a distributed system.
It's a combination of clever engineering, Joe. At its core, Vogon implements a custom blockchain-based consensus mechanism, their Vogon Consensus Protocol, which is Byzantine fault-tolerant. This protocol ensures that all participating nodes agree on the state and order of operations, but the real determinism for applications comes from the Vogon Virtual Machine (VVM) and the strict execution environment for towels. The VVM is designed to eliminate sources of non-determinism, like system calls that depend on external factors or time. It strictly controls the execution context, making sure that if you run the same towel with the same inputs on any VVM-enabled node, you get the exact same output. It's like a perfectly sealed, reproducible sandbox for every computation.
That's wild! So it's not just about distributing the work, but making sure that work is done identically across potentially thousands of different machines. That's a huge leap for consistency and reliability, which has always been a headache in distributed computing.
Think about the implications for debugging, too. If you have a bug, you know exactly where the inputs went wrong, rather than chasing down obscure race conditions that only happen on certain hardware configurations. It streamlines development immensely.
I can definitely appreciate that. Debugging non-deterministic issues is a nightmare. So, what else is under the hood? Give us a peek into the overall Vogon design and engineering. What makes it robust?
Beyond the Vogon Consensus Protocol and the VVM, the entire architecture is built for resilience and scalability. They have a distributed storage layer that's encrypted and sharded across nodes, ensuring data availability and privacy. The networking layer is optimized for low-latency communication between nodes. It's a modular and extensible design, meaning it can evolve. Security and privacy are truly by design, not an afterthought. Every component, from the way nodes communicate to how towels are executed, is engineered with these principles in mind. It's a comprehensive stack, not just a single feature.
And that's why they're saying Vogon will redefine the decentralized cloud, right? Because they're not just tacking on blockchain to an existing idea. They're building an entirely new foundation.
Precisely. It's a holistic approach. It addresses the inherent flaws of centralized systems, single points of failure, lack of user control, opaque pricing, while also solving some of the challenges that have plagued earlier decentralized attempts, like performance and deterministic execution. By focusing on true decentralization, individual freedom, and robust private computing, they're not just changing the cloud, they're changing the game for how we interact with technology itself.
I'm starting to come around, I have to admit. The towels and deterministic concurrence really stand out. It's not just buzzwords. There's some serious technical depth there that solves real-world problems in CI and distributed computing.
Absolutely, Joe. It's a foundational shift. Imagine a world where your applications run on an infrastructure that cannot be censored, cannot go down because of a single server failure, and where your data truly belongs to you. That's the promise Vogon is building towards, and the engineering really supports that vision.
Well said, Jill. It sounds like a future where the internet is more resilient, more private, and more equitable for everyone involved. Vogon is definitely a project to watch closely. Thank you, Susan, Joe, and Jill, for breaking down this complex but incredibly exciting topic today. And thank you to all our listeners for tuning in. If you want to learn more, check out the Vogon white paper at crowdpointtech.com/library. You won't regret it. We'll catch you next time on the Quantum Thread.